Hello, today we're going to learn about the Pythagorean Theorem, and I know you know about the Pythagorean Theorem, but we're just going to be doing it with simplifying square roots. Some small terms that you should probably know, but I'm going to throw them out anyway. The hypotenuse, it's always the longest side in the right triangle, and it's opposite of the right angle. The legs are just the other sides, the ones that aren't the hypotenuse. Uh, in any right triangle, a squared plus b squared is going to equal c squared. I think we know that. And C is always the hypotenuse across from this 90-degree angle. So really quick, if I wanted to find this hypotenuse, 15 squared plus 8 squared, we get 289, square root it, we get 17. On this one, our hypotenuse is 13, so that goes over here. 5 goes either A or B, it doesn't matter. Subtract 25 from both sides, square root it, we get 12. It's all nice and easy once we get nice numbers. But now, what's new is we're going to add things that aren't nice numbers. So if I want to do this one, I have 5 squared plus 10 squared is equal to c squared. That's 25 plus 100 equals c squared. So that's 125. Now when I square root it, I'm going to get 125. Now, in your previous years in middle school, what you'd do is you'd find a value and it'd be 11 point something, but that's not what we want right here. What we want is the simplified square root version. So we think about what's the largest perfect square that goes in this? 25, so that's root 25 root 5. And so it'll be 5 root 5 as our answer. I'll do one more over here. Uh, these move separately wonderfully. I'm going to move these down so I have more room. So right here, what I'm going to do is now my hypotenuse is the 12, so I'm going to say 6 squared plus b squared is equal to 12 squared. And I'm going to have my 36 and 144. And when I subtract 36 from both sides, that's going to be 108. Well, the square root of 108. I don't know what divides into 108 evenly. I think 36 does. Yeah, it's 36 and 3. If you didn't know that, you can use the other method where uh, you can, so you can say this would be 2 and 54, 2 and 27, 3 and 9, and this is 3 and 3. So we got a pair of 3s and a pair of 2s. 2 times 3 is 6. And that poor little root 3 is left all alone. He doesn't have any friends. All right. So we have 6 root 3 is the answer for this side. Or you could have seen that square root of 36 divides in evenly, and then whatever. All right. And so now we're going to skip a little bit. I'll let you find that stuff out. Now, if we want to find this one, so what's this is three-dimensional. So I want to go from this corner to this corner. And it's hard to see because that lines up so well. But I'm going to go up there. Now, we don't know what's the longest stick we can fix and fit in this box right away, but we could find this distance because down here that makes a right triangle, assuming this is a rectangular prism. So if I have 9 and 11, I can take 9 squared plus 11 squared equals c squared, and I have, you know what? I'm not even going to figure that out. I'm just going to square root both sides. So I have square root of 9 squared plus 11 squared. I could figure out the value in 81 plus 121, but I think it helps to not do that right now. So I'm going to say this whole side is the square root of 9 squared plus 11 squared. You can't read it, but that's what that is. Now, if I want to find this, we have another right triangle that contains the side we need. I'll outline it in red. So now, if I want to find that, I'm going to take 8 squared plus the square root of 9 squared plus 11 squared, and then I'm going to square that. That's going to equal c squared. Well, 8 squared is 64. I'm going to hold up. Instead of doing that, I'm so tempted to solve this problem. I'm just going to go one step further. I'm going to square this, so I have 9 squared plus 11 squared equals c squared. And now I can square root this. Now, so this longest distance here is 8 squared plus 9 squared plus 11 squared. 8, 9, and 11. Now, if I would have found the numbers, and I don't think it would be as easy to see. So there is a nice, easy formula for this. You could just take one side squared plus the other side squared plus the other side squared and square root it. And that would be the longest stick that will fit in a three-dimensional box. So we could do it out. We have, what, 64 plus 81 plus 121. And so this is going to be the square root of 266. And I'm not quite sure if anything divides evenly into that. I think that might be perfect as it is. I think that's simplified. Um, all right. So, oh, this breaks it down a little step by step. So this right here would be Pythagorean theorem in 3 dimensions. So three-dimensional Pythagorean theorem, a squared plus b squared plus c squared is equal to d squared, where d is the distance from one corner to the other.